Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our endeavor to model CO2 sequestration in saline aquifer using CMG software, which is very strong, very powerful software to model CO2 sequestration. And in previous videos, we have constructed the model in the builder section, but some something are lacking and we need to edit the model, and we will perform that using cedit. Okay, using this tool, cedit. But before going to that, I want to show you the data structure within the file that we have produced using builder. Okay, so by builder, using the builder, we produce this file, exercise one structural.dat. Okay, this is the name of the model, and the extension of the file produced by builder is .dat. Okay, as you can see, we can open and we can read the file using Notepad, and I will double click, and this is what we have inside the file. Okay, and of course I can do modification directly on this Notepad file if I want to, and it will be the same with modifying or exchanging or yeah, correcting the information within the builder. Okay. Okay, so this is what's inside the file produced by builder, like the title, okay, structural, and this is the setting for the result, this is for the grid, or maybe let me show you what happened if I open it in cedit. Okay, so let's bring this .dat onto cedit. Okay, or maybe we can double click first. All right. Oh, unfortunately, I have problem with my cedit. Okay, so instead of doing that in cedit, I think I will just go directly to edit the file in Notepad view. Okay, so let's double click on this one. Okay, so this is what we have inside the file using Notepad. As you can see, this is grid, vary, and this one is 100 blocks to X direction, 1 in Y direction, and 20 in Z direction. And then K layer, the direction will go down. Okay. And this is the, the size of each grid block. So in I direction or X direction, it will be 10. So 100 multiplied by 10. This is only, in J direction, 10. Okay, so 1 multiplied by 10, something like that. Then this is the depth of the top reservoir. It's at 1,200 meter. And this is for the porosity, 18%, permeability in I direction, 100 millidarcies, and then permeability in J direction equals I, meaning it will be equal with permeability in I direction, 100, and also the same for K direction. So it is a perfectly homogeneous reservoir. This is for the compressibility and model PR. So Peng-Robinson model is used here. NC for number of component. Okay. And the component name is CO2 and CH4. So CO2 will be the first, the number one component, whereas CH4 will be the second component, the number two component. Okay. And then reservoir temperature, 50, viscosity, and then viscosity or coefficient, molecular weight, eccentric factor, critical pressure, critical volume, critical temperature, paracore, all right, and omega A, omega B, okay, and this is the permeability, I mean the relative permeability, okay, liquid and gas system, initial condition, all right, so this is the mole fraction for the gas, 1, 0.001, okay, for for the CO2, and the rest will be for the methane. Reference pressure, reference depth. This is the gas cap. And this is for the numerical control. We already have DT max 75, DT min, and others. Ether max 200, run, and then for the well setting, okay, we will operate, or the constraint for the operation of our well. So this is for the surface rate. This is for the maximum bottom hole pressure. This is for the completion or the perforation located at which grid. This is the grid location. And this is for the injection schedule, the date. All right. Beautiful and very simple. Okay, so that's it. And it's still lacking. That's why we need to put more keywords to complete the file before running it using the gem. Later, we will run the simulation using gem. Okay, so here we go. We first check the numerical control. Make sure that we already have DT max and DT min. Yep, we already have that. And now we want to go to the fluid section. Okay, under the model keyword, right? This is the model keyword. So we will go down. Here we have aqueous viscosity casting. Okay, before wind prop, let's insert something here. I'm going to input the density of water at surface condition, and the keyword is DEN, density, W for water, and S for the surface, and the value will be 1020. And I will make this note. This is to specify the density of water at surface. Okay, so the keyword is DENWS. And trace comp. All right, and I want to use, or I want to consider the second component as the, as the trace one. CS4, the second component on the list is the trace component. Don't forget to save. All right, pretty much that's all. And I think one more. Okay. Actually, in practical point of view, you don't need to perfectly memorize everything. You have manual, you have guideline, you have your friends to discuss about it, to learn from, and of course you also have software support. So there is no need to perfectly memorize all the keywords and the codes here. And lastly, I want to go to, or I think it's already good. Okay. Just make sure, do I have IO below and up? Okay, let's read it. The following is the fluid component property data. The unit and fluid composition should be specified in input output control section. And then let's check another. Okay, I think it's already good. So the next one will be where we, run the simulation using GEM. Okay, until then, thank you so much for watching and see you.